So let's take a look. So in Chapter 6, we've been talking about winds, and the thing that creates wind in the first place is air moving from a high to a low pressure. So I can already tell you on your test, probably in a couple of different types of questions, it's going to be asking you that, because I think it's important. High to a low. Right? Then the other thing is we talked about the Coriolis force, okay, and we're actually going to see that again today. Okay, that the Coriolis force, what direction does it deflect wind to in the northern hemisphere?
Right.
Right, to the right, exactly to the right.
You just showed
the the cyclone, or the merry-go-round, yeah.
Yeah.
Every time you
Ah,
throw the
that's a
ball,
good
it goes
video.
to the right.
Psych, yep.
I want to do that.
Which technically you could just move a person to that area and then they would catch it.
That's true, you can anticipate, right?
You could.
But the other thing, so we have wind created by, what's PGF stand for? Pressure gradient force, yep. We have wind created by the pressure gradient force from a high to a low. We have Coriolis force deflecting. The next thing we need to talk about is friction. I have a couple slides here, and you probably already kind of know what friction does. It slows down the wind. So here we go. They're kind of hard to see, but you see kind of our little gray isobars here. Okay, these are the isobars. This is high pressure. This is low pressure. So the pressure gradient force is in red right here. Okay, this red right here is your pressure gradient force. The blue thing is your resultant wind. Okay, so pressure gradient force, wind. You would think wind would go from high to low, but it's deflected, like you told me, to the right, and that's exactly what you're seeing, that deflection. Now friction is going, the purple thing, it's going backwards. Okay, makes sense. It's opposite the direction of motion. That's it. Now, how big the arrows are in science is how big the force is. So, for instance, here we switched from like a rough surface to a smooth surface. So, what do you think it would friction? Did it increase or decrease?
Decrease.
It would decrease, yeah. And so, if we actually find our purple arrow over here, that's what we see it decreasing. Exactly. So it's all kind of working out. Okay. So, what happened to the wind? Is it stronger or weaker?
It's the same, but it's over different topography.
To me, it looks a little different. How would you say kind of the length of the blue arrow?
It's longer over there.
It looks shorter over there
Yeah.
and longer over here? Yep, it's longer with the less friction. So it's just kind of trying to show you that. One more then is this one, which is basically kind of maybe at upper elevations where it's just wind. There's nothing to rub against. So wind, air underneath it. So, wow. So here we have from high to low, just like we've been looking at. So this is from high pressure to low pressure. The red is our pressure gradient force. Now, you would think that wind would go from a high to a low, but you guys told me deflection is to the right. Okay? So actually, we have deflection to the right all the way to basically it goes between isobars. Starts with the letter G. What kind of wind do we call that? G, not gradient. Gradient's around curvies. Geostrophic wind, exactly. That's a geostrophic wind. Nice straight between isobars. Yep. And that's what it does at upper elevations. Okay. So that's kind of friction and, all right. So that last one was kind of at upper elevations. We're back to the Earth's surface again. A lot of times when you look at weather maps, they're going to be surface maps. At the Earth's surface, a lot of times we have these kind of bullseye sort of looking pressure forms, okay, where we have a central low here on the right and a central high there on the left. These are terms that we talked about earlier, I think probably on Wednesday, because we know that if it's a high, we call it an anticyclone. Sounds so mean. Okay, and highs, we said, in the northern hemisphere are going to go clockwise. So can you kind of see the little wispies going clockwise? Okay, and lows are cyclones, and they will go counterclockwise. Yep. And then also you can see these lines, these have the millibars of pressure. So if it is a low, let's pick on the low here. If it is a low, we should be stepping up. So we go 992 millibars, 996 millibars, 1,000 millibars, 1,004 millibars. We are kind of stepping up. We could do the same thing. Now, with the other one. Now, what this emphasizes is this kind of, and the next slide we need to talk at 3 dimensions. So I'm just going to go ahead and draw our anticyclone and draw our cyclone at the surface. So one of the things we know is that air will be going outwards from here. Kind of makes sense. And it'll get a spin, and it'll be going, clockwise, right? Air will be going towards the center here because it's high to low. Does that make sense? Now, the next few slides are just going to kind of talk us through if, for instance, let's talk with the anticyclone. If this air is leaving the center, does that not make sense that if it leaves the center, you're going to kind of leave void of air, you're going to leave a low pressure behind? Okay, so we need to fix that, and actually Mother Nature fixes that. I'll show you. I'll kind of give you a hint. Basically, a chunk of air comes from, now, this is the ground, so we're kind of turned our earth here, okay? Basically, from upper elevations, a chunk of air comes down and replenishes that air that's leaving. Okay? That's for a high to be sustained. Now, for a low, we got a different problem. A low, we basically have air coming here, and it's going to, what we say, convert from a low. If you get a bunch of air together, it's not going to be a low anymore, is it? It's going to be a high. Okay? So the low has a problem, too. The cyclone has a problem. Basically, that low is going to be changed to a high. So what it needs is to get rid of air. And so what it does is basically, you're going to see on the next figure, basically air comes up from there. Okay, so that's kind of what happens. Okay, so for anticyclones, right here, for anticyclones, where you have a high pressure in the center, okay, you need to, if you want to keep that high, you have to have air coming down in the middle, basically replenishing it. Okay. Now, one of the things about if this is air coming down and replenishing it, if you take a chunk of air and make it go down, it doesn't expand, it contracts. And it doesn't cool, it warms. Yeah. So a lot of times, like the slide says, we call that subsiding air, subsiding, like if it's going down, subsiding air. That subsiding air is warm, and it doesn't really have, you don't have clouds there. Okay. So if we compare that to our cyclones. So here's our cyclones. We said if we're not careful, basically the cyclone is going to have air pile up, and it's going to go from an L to a high. So it needs to get rid of stuff. Now we have a different situation. It's like a lifting mechanism, okay? Basically, air is going to come up this way, and as it rises, it's going to expand. As it expands, it's going to cool, and if there's moisture there, you can get condensation. So that's why this says, oftentimes associated with our L's, our low pressures, oftentimes we can see clouds and maybe even precipitation with our lows, with our cyclones. Okay? So here's the picture that goes along with what I just said, the last two slides. Okay, we have our cyclone, our anticyclone over here. I said in order for it to stay at H, you need to have air coming down. That's exactly what this is showing. Okay, over here we have our cyclone. In order for it to stay low, okay, we have to basically get rid of the air that's piling up, so it will go up. And I don't know if I emphasize it very much, or I don't think it's a homework question, but there's one more kink to this, no pun intended, okay? If we start with the anticyclone, how are you going to get air to come down? Well, actually, you can get air to come down if there's a kink up there at upper elevations, so it kind of piles up, it comes down, and it helps support your high. Similarly, how are you going to get air to go up? And so your low can be sustained. You basically kind of have, opposite of a kink, you have divergence at upper elevations. So that actually is kind of all goes together. So, and I think I mentioned it before, we're going to talk about weather forecasting, like how can you predict whether it's going to rain or what kind of temperatures we're going to have. And it's complicated because we definitely have this kind of multi-layer all working together for us little people down here, what we care about.
I have a question.
Mm-hmm.
The word cyclone to me is what I hear when they have them in the Pacific, and it is very high winds and lots of damage.
Yes.
Is that always true, or is this just a natural phenomenon that occurs?
Well, So the cyclone that, are you talking about, are like an over water or over land or?
Usually they start over water and then go over land.
Okay, so I think what you're describing is probably, if you were to look at a weather map, it'd be one big old L, cyclone. Regardless of what hemisphere it's in, it's a cyclone. L is a cyclone. And it has, similar to what we've been talking about, you'd have rising air there. And, you know, so I think we're kind of on the same page there. The things we call hurricanes, a generic name for a hurricane is actually a tropical cyclone. So, yeah, hurricanes are tropical cyclones. And in some necks of the woods in the world, actually they call tropical cyclones cyclones. So that's kind of why, so hurricanes and cyclones sometimes are the same.
And typhoon.
Typhoon is another name for a tropical cyclone.
Is there a certain part of the world that?
Yep, and your textbook has a map of who calls it what. Yeah.
Is that like an India area?
I think so, typhoon. Yeah, I do think it's in Asia. Very good. So, I'm hoping that you kind of have a sense for kind of horizontal movement of air, and we just now talked about vertical movement of air, kind of that column of air that's either going to go up for to sustain a low or come down to sustain a high. There's a couple other ways to get vertical movement of air. One of them is that, let's see, these kind of both go together. It kind of depends upon the, like the surface it's blowing over. If, for instance, it's blowing from something smooth like the sea onto something rough like the land, you might imagine it kind of piles up, and that's actually a way to kind of get it piling up, and as it piles up and creates a high, it will want to go up vertically. It's a possibility. The other one is if it goes from something rough like land to something smooth and glassy like that. What that's going to actually do is create kind of a vacuum as it speeds up over the smooth water, and it can create descending air. Okay, so those are two ways. And another one we kind of talked about just in general, if you slam it against a mountain, we call that orographic lifting. It creates a high and it goes that way. Okay. So we kind of leave with, if the wind's blowing, how do you describe it? If the wind's blowing, how do you observe it? So this is one way you can describe the direction of the wind. I think I mentioned before, though, in meteorology, we usually say the direction it's coming from. So if somebody says it's a westerly wind, it's coming from the west. Okay. So one way is if it's a westerly wind, you could say it's actually blowing at an angle of 270 degrees. Okay. What if it's a southerly wind?
180.
180, yep. So that's one way to kind of go. That's called an azimuth, kind of pretty. This is another very common way, though. This reminds me of farmers who would kind of be specific about this. So if you say, it's coming from the west, that's fine. If it's coming from the north, that's fine. But you guys know it could be coming from the northwest, okay? But if it's in this quadrant, a little bit closer to the north than the northwest, then it's the north-northwest, okay? Yeah. And if it's a little bit closer to the west than the northwest, it's the west-northwest. So, I don't know. It's just kind of how that goes. You're probably familiar with it. And then we have this one, rose winds. I think this is cool. It's an icon. A rose wind is an icon. And we're going to talk more in after break about prevailing winds. But a prevailing wind is just one that you're pretty sure is going to be there. Just that time of year, that general location. So prevailing winds. So here's a rose wind. It's an icon, like I said. The longer the segment, then the more the wind is coming from that direction. So when I'm looking at here, it looks for this location, this general time of year, their prevailing wind is out of the northwest. After the northwest, where do you think it's coming from? Second most common.
Probably west.
Probably west, northeast. How about where does it least likely come from?
South.
Southeast.
Yeah, southeast. I agree. Very good. Rose winds. Here's another rose wind. This is actually on my bucket list.
What do they call it, a rose wind?
Why do they call it a rose wind? Maybe because it kind of looks like a flower, and it talks about wind. Don't know.
I like it.
But Australia. Where's the wind coming from most of the time?
Southeast.
Southeast, yeah. And actually, if you want to put that in the back of your mind for a week or so, we'll talk about kind of the prevailing wind here in that neck of the woods coming from the southeast. So just to kind of finish up, ways that you can see, kind of measure the wind, okay, determining how fast the wind's blowing. This is something you might see on those ASOSs. So I'm hoping you guys remember what ASOS, ASOS, Automated Surface Observing Systems. They're the ones that they have by airports, and they just kind of automatically send them some data. But what happens with a cup anemometer is they're little cups, and they catch the wind, and they spin around, and then they can take how fast it's spinning and convert it to wind speed. And then, of course, this will give you wind direction with the fin.
What's that stand for again?
Automated Surface Observing System. ASOS. Sounds edible, but it's not. So this one is really common, like at airports. You know, you can do a lot with wind sock like that, because the wind sock kind of rotates a little bit. So however it's swinging, you can kind of see the direction of the wind, and however inflated it is or not inflated it is, you can kind of get a sense for how fast the wind's blowing. So it does both. And then we have an aero vane. So an aero vane has the propeller part, which will give wind direction. There's the propeller part, kind of like this propeller part, but it also has a blade that will spin around depending upon how fast the wind's blowing. So again, they can take this rotational speed, go down here, and translate it to a wind speed. Just recently, I'll tell on myself, went to that spotter training, and I was motivated to buy, and I'll bring it in one of these times, wind meter, like a little handheld wind meter. So
Stand outside and.
yeah, geek. Yep. What's the wind doing? Oh, I guess there is one more slide. So there are other ways that meteorologists can determine the wind. One of them is using those weather balloons. Now, we talked about weather balloons, but we didn't talk about looking at weather. If they're looking at wind, there'll be a raw and sound. You see that raw and sound? That'll be kind of the box that's part of the weather balloon. The normal one we talked about were the radio sounds. Radio sounds, raw and sounds. Raw and sounds are wind, speed, and direction. Radio sounds are the other stuff. So that's a thought. And then this is the last one. Basically, a satellite image of clouds. And if you watch the cloud movement, you can get a sense for what is moving the clouds, of course, is wind. And we kind of looked at this convention before. You kind of see the flags. The more the flags, the faster the wind. So cool. Well, let's take a quick look at your Chapter 6 assignments. So you guys want to... It looks like... Hopefully. Yeah, I think it looks like this. So the first question, I'm going to go ahead and grab my sheet too. The first question probably does not have an asterisk next to it. So this would be using complete sentences. It says, if a weather system, so you guys answer this together, and I'll type you right now. If a weather system with strong winds approaches Lake Michigan from the west, how might the speed of the winds change as it goes across the lake? Anybody?
I think it would get windier.
I do too. I think it'll blow faster.
Mm-hmm. That's why it always
Pick up
seems choppy when you're out on a lake.
Oh yeah, that's
I
true.
don't really know.
Friction to slow it down.
Yes, yes, and yes. No friction to slow it down. I'm liking it.
And the waves go everywhere.
Yeah. That time's coming.
My dad warned me about that.
So this next one, let me see if there is an asterisk next to 4. Yep, there's an asterisk. Means you don't have to use complete sentences for this one. So there's this weather map that goes along with number 4. And it says, which of these are anticyclones and which are cyclones? So notice that we have numbers 1, 2, 3. And I have that answers.
So one's anti.
Why is it an anticyclone?
Because it goes. Anticyclones go clockwise, right?
Well, you can't really see it moving.
No, I'm just asking.
Oh, anticyclones go clockwise, yes.
Because the pressure is low.
Well, can you tell whether, for instance, if we pick on one, can you tell whether the pressures are getting
Getting higher. as you
higher?
go out.
So if it's getting higher as you go up, then what is it? It's a cyclone. It's a low. I think you guys both can see how this is 996, 1000, 1004. It's getting higher. So that means this is a low. Yeah, so it's a cyclone. Yep. What about number 2? 2024, 2020. I heard somebody say high. You buy that? Does it seem like a high? Because it's kind of stepping down. I'm like an anticyclone. How about number 3? It's 972, 976, 980, 984, 988. You saying cyclone? Yep, with an L there. Yep. And I kind of think of it, actually, I put my L there and then I think cyclone. So, but either way, it's all the same diff. Well, how about B? B says, of those 3, which one looks like it has the steepest pressure gradient? How many people think it's 1? How many people think it's 2? Steepest pressure gradient. How many people think it's 3? I do too, yeah, because they're so close together. Does that make sense?
So the closer are these isobars?
These are isobars, yep.
The closer together they are, the faster the wind is.
Yes, the closer together they are, the faster the wind. Yes, yes. And the last one, I'll just kind of let you refer to that one. It says you need to refer to a figure to see if that number 3 that you said had the strongest pressure gradient, which it does. It said, should it be considered weak or strong? Probably strong, I'm thinking, yeah. Okay. The next one looks like this. And actually over there in purple and blue, I kind of reminded you clear back at the beginning of this chapter, we kind of talked about that aneroid barometer or the barometric pressure. And if your tendency is for the pressure to go up, that's what this arrow means. If your pressure is rising, that's what the arrow means. If the pressure is rising, expect clear skies. And then we generally would call that a high pressure. If your pressure is falling, okay, expect cloudy skies. And we would generally call that like a low pressure. So that's my hints for these, and we won't go through each one of these, but.
Clear skies, and what did you say?
And
Low pressure.
clear skies, high pressure if the barometric pressure is rising. And if the pressure's falling, cloudy skies and low pressure. So that was number 6. So that one has an asterisk, so you don't have to use complete sentences. And then we go on to 8, and you do have to use complete sentences. Oh, it's a rose wind. So 8 looks like this at the top there. It says you're designing an airport and the airplanes need to take off into the wind. And I'll just let you guys answer this. But based upon this rose wind, what direction is the wind most likely blowing from?
Northeast.
Northeast, I agree. So with that in mind, answer the question.
So they want to take off into the wind?
Yeah, take off into the wind. So what are you thinking?
Probably head
And it's
east.
coming in from the northeast.
It's
so
coming
they
from
probably-
the northeast, so you want to go southwest.
I'm kind of liking that. I don't mean do your homework for you, but that seems right to me too. Yeah. Yep. I'm thinking from the south, approach from the southwest. Then the last one, it says your friend says that he heard the weatherman say that the barometric pressure is 28.8 inches and rising, and he's scratching his head. He's like, can you explain this to me? Because I know you're taking this class. And the meteorologist also says it looks like fair weather is on its way. And so notice I circled the word rising. So to me, and your friend is saying, how does the meteorologist know that? Because it goes back to what was on the previous slide. If the pressure is rising, we can expect clear skies. Like this spring break, it's going to be beautifully clear skies the whole time. Yay. And then he goes on to say, the first one says, It said, I thought air pressure had something to do with the weight of the air. What's up with the inches? What's up with the 28.8 inches? And my little hint was a mercury barometer. Remember? Basically, the greater the pressure, the farther the mercury goes up in the barometer. And when the pressure is less, the mercury falls down. So, okay? So those were those. It's fun to hear you guys do your homework. So I think that's it. So let's take a look a little bit at the next chapter.